applications for chapters 11 and 12, application number 2.
Okay. Let's start there then. Sounds good. Hey, Tommy, welcome. Let's see. Here we go. And applications. And chapter 11. Oops. Make sure that is on mute. Yes, it is. All right. So let's see. It was on application 2, Julia?
Yeah.
Okay.
I just wasn't really sure the next slide 4 or
Yep.
5, I think.
Right here.
Yeah, so I just wasn't sure how that kind of translated into the formula sheet. It just took me at it. I wasn't really able to understand it.
Okay. Let's see. Let me grab the formula sheet at the same time here then. Oh, so you're thinking about this right here, right? Is that the beta here where it's rho times sigma I over sigma m?
Yeah.
Okay. Yeah. I can clarify that. So either one of these is a correct version of that. So this right here, if I were to write it the way I would, it's covariance of the market and the security, let's just call it I, over the variance of the market. That is the exact same thing as what's on the formula sheet, which is the correlation between the market and security I times the standard deviation on security I over the standard deviation on the market. So this is exactly equivalent to that. You can use either one of those. In fact, I'll add that to the formula sheet if that helps. Let me just make myself a note so that I can. All right. So, and then, in terms of actually calculating it, covariance of R sub m, R sub I, if you go to, I think I've got that in other formulas at the end of the formula sheet here. Yeah, so right here, you would use this to get your covariance, and you could use that, this right up here, to get your variance. And this E of R sub I, and down here, E of R sub I and R sub J, those are just simply the means, right? The estimated means. And you can substitute in the market for either one of those, whether it's I or J, doesn't really matter. Is that what you were asking about in particular?
Yeah, that helps a lot.
Okay, all right. Great. Excellent. What else can I help with?
I have a question.
Yeah, go ahead, Catherine.
Could you either go over, show which equations to use for chapter 10 from the homework for questions 1 and 2?
Sure.
I was looking over that to figure out which ones to use.
Would that be questions 1 and 2 out of the applications in that chapter or out of the homework? Homework problems. Let me go see what those are. Oh, they were in Safari, so. Let's see. Oh, here we go. Okay, does this look familiar? Can you see that? Aloha Inc. has a 4.5% coupon bond on the market that has 6 years left to maturity. If the yield to maturity on these bonds is 8.2%, what is the current bond price? Is that one of them?
Yeah, it looks like the one I had. Just
okay. All right. For this one, I would simply, you could use a formula to do this, but what I would do is to use my calculator. So let's see. The only potential snag here is this an annual bond or a semi-annual bond? And the kind of the protocol that your authors have taken in this chapter is, if you're not told differently, to assume that it's a semi-annual bond, which is what most bonds are. And then also assume a $1,000 face value. So then all we're doing here, let's see, let me just jot down. So we've got a 4.5% coupon, 6 years left, 8.2% market yield, or market rate of return, market required rate of return. So we're looking for price. And I'm just going to go back here to the blackboard. So I'm going to calculate my my n is going to be 6 times 2, because I'm dealing with a semi-annual bond. My payment is going to be 0.045 divided by 2 times $1,000, which is going to be, what, $22.50 per period. My future value is 1,000, and my yield, or my Y here, is going to be 8.2, which would be 0.41 or 4.1%. And that should give me an answer here. So I plug in 12 for N, coupon of 22.5, future value of 1,000, and a yield of 4.1. I get a present value when I plug those in of $8.27 and 38 cents. Is that what you got when you worked that problem?
Yeah.
Yeah, and there we go. So that, I wouldn't even, the test is going to be all multiple choice, so you're just going to be looking for the answer. Now, another way to get to that, we could use a formula. And that would just simply look like this, that the price of the bond is equal to the sum from n equals 1 to 12 in this case of the cash flow sub n divided by divided by 1 plus, let's call it y, raised to the nth, and that would do it. So what you're going to have is a series of cash flows. The first 11 are simply $22.50 divided by 1 plus 0.041 raised to the first, and then 22.5 divided by 1 plus 0.041 raised to the second, and so on, until we get to the 12th cash flow, and it's going to be the $1,000 plus the $22.50 final payment divided by 1 plus 0.041 raised to the 12th. And when you do that, that still ought to come out to that 827.38. But that would be the, if you're looking for a basic pricing formula, that would be it. So it's just the sum of all of the discounted cash flows. And let's see, let's look at number 2. Rolling company bonds have a coupon rate of 7.2, 20 years to maturity, and a current price of $12.46. What is the yield to maturity? And what is the current yield? So let's do that in reverse order. Let's see. Coupon rate is 7.2. All right. So there I would take my my 7.2%. And again, we're assuming semi-annual. So 3.6% is my semi-annual coupon. So 0.036 times my 1,000 gives me $36. And that's on a current price of $12.46. So divide that by $12.46, and I get a current yield of 289. So when I put that on an annual basis, that would give me 5.78%. That's my current yield. Remember, current yield is simply the coupon divided by the current price of the bond. That's my current yield. Now, to get the yield to maturity, we could use that same price formula. 1 to, in this case, 40 cash flow n divided by 1 plus y raised to the nth. The only problem here is that we're trying to solve for this y. So you could do a hunt and peck and kind of, pick a y, and knowing that the price is above the face value tells us that the yield is going to be below the coupon rate. So you could start, that way. But again, the calculator is really the easiest way to get to that. So we've got an n of 40. We have a payment in here of, what was it, $36? We have a face value, or future value rather, of 1,000. And we have a current price, or a present value, of 12.46. So when I plug that in, future, let's see, PV of 12.46, going to make that a negative. And then my 1,000 future value, my 36 payment, 40 periods, and I calculated YTM, and I'm getting 2.6, so that would be 5.2% is my yield to maturity. Hopefully I got that right. Yeah, there we go. Any others out of that chapter while we're in here? Everybody okay with the duration pieces of this as well?
I'm kind of having trouble with the duration
Mm-hmm.
when I was doing the application for chapter 10.
Okay.
I could do it, I think, when I use the cash flow formula, but then when I tried to use the shortcut formula for some reason, I just would never get the right answer.
Okay. One way is keep using that summation. I know that if there are a lot of periods, then it does become a problem. I think the only trick, and let me go back over to, where was our formula sheet here? Here we go. Um, the only trick to that formula, well, at least one, make sure that you're using the correct version of it for the app, for the particular situation that you're in. So one would be you've got this par value bond, which is going to be rare, but we could still have a problem like that on the test. So there you've got a bond that's priced at face value. So it's $1,000 price with $1,000 face value. Then you can use this formula right here, the 1 plus YTM over 2 divided by YTM. And by the way, that's still semi-annual. If you have a bond that is priced at other than face value, then you have to use one of these two. And the top one is again, assuming semi-annual, and the bottom one is assuming annual. So there, the key here is that you're putting in the CPR is your coupon rate, and your YTM is your annual yield. And in both cases, you can write it in as the annual rate, right? Because, for instance, over here, we see that we're dividing that by 2. And over here, we're dividing it by 2 as well, right up there. Oops, my hand is disappearing on me, sorry. So was there one in particular that wasn't working out for you?
I think it was like the duration annual one because I was just doing the application for chapter 10.
Okay.
It was.
Let's try that and see.
Okay. Yeah, it's like slide 5, I think.
I thought I had checked that one out because I rewrote that, and I think it's right, but I could have had an error in there. So we've got a 6.5% coupon annual, face value of 1,000, maturity of 5 years, and a 7.5 market required rate of return. All right. So the first step in both of these would be to simply price that animal. Actually, I take that back. In the shortcut formula, you don't even have to get the price, so that saves even more time there. So here, when we do get the price, let me just confirm that I got the right numbers here. We've got a $65 annual coupon. We have 5 years till maturity. We have a 7.5% market required rate of return, an I or a Y there. Face value is 1,000. So we're computing PV. Yeah, I get 959.54. So that part of it is correct at least. And then here we want to do our summation. Actually, speed that up. 3, 4, 5 years. Control. Oh. Okay. So that doesn't work in. Oh, there we go. We're going to discount these at 7.5%. I'm going to put my years out here. This last one is going to be 160,065. And let's see here, I want to sum that up. There's my 959. So I want to get my percentage that is of the entire price. Make that. And that should also sum to 1. Good. And then just going to take that times my period. And again, sum. There we go. Okay, so at least that slide is right. I just wanted to double check that slide number that we got here. So basic, do you see where I got those numbers all from?
Yeah, that one makes sense.
Okay.
And I think, yeah, I was able to do it that way. But then the shortcut formula, it's probably just a me problem, like putting it into my calculator wrong.
You know where I think it might be? So that should be, the way that should be written is this is a plus, this is also a plus, and a plus, and a minus, and a plus. The formula sheet actually denotes this as M, maturity, or capital T time to maturity. This is a -1, and then this is a plus Y. So my guess is that it might be right in here where things went amiss. So the first thing you want to do is to do that piece inside the brackets. And so 1 plus our Y is our market required rate. So that's the 7.5 or 0.075. So 1.075 raised to the 5th power, because that's our time to maturity. I get, for this piece of it, I get 1.4356. Oh, and then I want to subtract 1 off of that. Sorry, my bad. So actually that's 0.4356 right there inside those parentheses. And then I want to multiply that by the 0.065. And for that I get, so I'm, getting 0.0283. I'm just going to round that to 6. And then I can add my 0.075 to that. And so for the entire denominator, this piece of it right here, I'm getting 0.103316. And then let's do the numerator. Let's see, let's do the, I'm going to do this term first. So the coupon rate is 0.065 minus 0.075, negative 0.01, times 5, negative 0.05. I'm going to add that to my 1.075. So for the numerator up here, I'm getting 1.025. Are these numbers looking familiar?
Yeah. Mm-hmm.
Okay. Oh, and by the way, this is a minus here. And so I've got 1.075 over 0.075. Oops. So there, that's crazy. That can't be right. Yeah, 14. This gives me 14.33. So now I have 14.33 minus the ratio 1.025 over 0.103316. So let me do that ratio. Divide by 0.103316. So that gives me 9, I get 9.92. So this ratio right here is 9.92. So I'm subtracting that from the 1433. Yeah, I get 4.4089. And I didn't carry all the decimal places, so I'm sure that'd get close. So I think it's just probably order of operations. Be really careful down here in particular. And if you kind of work it through the way I just did it, you'll have less likelihood of making a mistake. I think that's the real fly in the ointment. It is a shortcut. It's a little faster, especially if you've got a lot of periods. But what you might want to do if you have time, which I'm not adding any more questions to the exam, but you guys do have an extra 35 minutes or so. So if you do have time, what you might do is even check it out with the long form version of it. Does that help?
Yeah, it does. Yeah.
Okay.
And then I did it too, and then I got it. So
Okay. Yeah, that order of operation is easy to get fouled up there, and those brackets help out a lot. But even that, I think you want to write down these subtotals as you go along, and then that way you're less likely to run afoul of different order of operation errors. What else can I help with?
I'm still kind of confused on the protective puts as well. If anyone else is confused on that, but if no one is, I can just watch the videos again. But
yeah, but we're here. I'm happy to go over that. Let's see. Is this was this our protective put? Suppose you bought a share of 50. The current price is 70. You're concerned about? Yeah. Would this one work? Looking at this one?
Yeah, I haven't done that one yet, but I was just looking at the graphs in the PowerPoint.
Uh-huh.
And I just wasn't really wasn't understanding those.
Sure.
Or you could do the application ones. But...
Yeah. Let's go over that, because here we bought at 50. And we're out here, so that's 50. We're out here at 70. And so you can look at this. We've got a $20 gain embedded in there. So there's our gains and losses. So that's our stock position. And what we try to do with something like a protective put is to put a floor. We call it putting a floor under something. So in other words, if price were to fall, it could conceivably drive us into loss territory, not only erase the gains that we had, but also put us into a potential for a loss. So anytime we're looking at these, the way to hedge whatever it is to get the opposite slope, and that's going to offset. So one way of hedging this is to short the same position. That completely takes us out of the market, though. So what we could do is we could short the stock at 70, and the net of this line and the original stock position, that net would be a horizontal line that runs all the way across at $20 gain. So we are both long. There we go. We are both long and short. So it's as though we both bought and we sold something. So we're basically getting our profit, and we're effectively out of the market. Now we could cover that short position, or in other words, remove that short and keep the share that we had. That's kind of another way of approaching it. The problem with that is that there are potentially different tax consequences there, and it takes us entirely out of the market. It doesn't give us any potential for the oops, I keep going there. Wait, yeah, I want to go this way. It doesn't give us any potential for upside. That flat orange line erases any potential upside, but it does lock in our gain. The other way to do it is simply sell the stock, and I get the same line. So, barring that, though, the options provide us with kind of a middle ground, if you will. So again, we've got our stock position. Oops, there's the right spot, $50. There's our 70. There's our current gain of $20. And so the idea of buying a protective put, so the protective put costs us money. It's flat to the right of the exercise price, and it's upward sloping to the left. And so what that effectively does for us is we pay this premium right here. So the gain on our stock at any time in the future is diminished by the amount of that premium. But we do have upside gain. So all I'm doing is I'm taking this premium, and whatever I pay, I paid it, and that's just going to be a loss no matter how much higher the stock price goes. And so that's how I get this line. I've just gone down below the stock value by the amount of the premium. And then when I get to the left of the exercise price, when I get over to this side of it, then the stock continues to lose money. But in this case, my put option is in the money, and I'm making $1, and I'm losing $1 on the stock. So what that does is that cancels out, and that gives me that horizontal. Now, it's below the gain that I had originally had prior to putting in the protective put by the amount of the premium. It's down below so if that's $2, then instead of locking in a $20 gain, I've locked in no less than an $18 gain. But the big difference is that I still have that upside potential. Remember, this is only an expectation about what's going on in the future. I don't know for sure the price is going to go down. It could go up. And so if it does go up, the benefit I get out of putting in this protective put is that I still get that upside potential. I still get, this piece of it here at the same rate, but I paid that $2. So my net gain is always going to be $2 below. So if the stock goes up to $75, if I hadn't hedged, I'd be another $5 ahead. But because of this hedge that I put in place that cost me $2, I'm not $5 ahead, but I'm still at least $3 ahead, the 5 minus the $2 premium. And that's true at $80. I would have been ahead by another 10, but because I put in this hedge, I'm only ahead by 8. Does that help clarify a little bit? Is that the direction that would?
Yeah.
Okay. Yeah, these payoff diagrams are hugely beneficial. Now, I know that when you're first learning these things, what I'm doing here, kind of freehanding it, is not something that necessarily makes sense to the neophyte option trader. I actually put together a few rules when I teach 444. If you've got two horizontal lines, you add them together, you get another horizontal. If you've got a horizontal and a sloping line, it's always with the slope, reduced or increased by the amount of the difference on the horizontal. If you have two slope lines in opposite directions, they cancel each other out and they become a horizontal line. And then there's one other possibility. If you have two slope lines going the same direction, it doubles the slope. So, for instance, if I had two long positions, or instead of buying a protective put, say that I don't know, let's say I bought a call. So a call would have this shape to it, and so here my net. I hope this is not adding to confusion rather than reducing it. Let's see if I were to draw my lines here. So my net position on the stock below the exercise price would be this blue line. And then above the exercise price, it actually increases its slope and goes up at twice the rate. We're not going to have any of those, but you get the idea that with those few rules, you can actually do this freehand. The other way to do it is to simply do it as a table and have, in the case of the protective put, I would have a table that has the stock position, my put, and the net of the two. And so I would also pick different dollar amounts. So I could pick 60, 65, 70, 75, 80. And that ought to be enough. If I've got at least 2 points on either side of the exercise price, I can pretty well tell which way it's moving. So at 60, I have a let's see, I have a $10 gain on the stock because I remember I bought it at 50. Here I have a $15 gain. Here I have 20, 25, and 30. And then on the put, at 70 or above, I just paid out the premium and I get nothing else out of it. So I have a $2 premium loss on those. If it's below 70, so $5 below, all right, so it's down, let's see, it's down here. That means I've got $2 before it breaks even, and then another $3 below that. So I'm going to be $3 ahead, and here I'm going to be $8 ahead. So there, when I start netting these out, I've got 10 plus 8 is 18. 15 plus 3 is also 18. 20 minus 2, 18. So I'm getting my plots here. So here's my 60. Here's my 65. So here's that 18, 18, 18. And then 25 minus 2 is 23. So there's 23. And 30 minus 2 is 28. So there's my 28. So now I can plot exactly what I did just by eye. So you might even look at that, doing it as a table, because especially when you're starting out, kind of doing what I've been doing just by eye is difficult. It doesn't make a lot of sense until you've seen it a few times in table form.
Yeah, no, that table really helped.
Okay, good. And this, you can do this with any number of options, stocks, short, long positions. You can set them up so you can have more columns in there. And remember, the key is that you just want to net them out at the end of the day. You want to net across all the columns, except this first one, this current stock price. That one, tells us where are we on this x-axis. But these two, and anything, if you had 2 or 3 more, you would net all of those out into this final column here. What else can I help with? Brett, you have any questions?
No, this would have been one of the things that I would have asked about, as well as the duration. I was kind of a little sticky on, but
All right. Spencer, anything that you were thinking about?
No, you answered everything.
Okay.
I was curious about. Thank you.
All right, very good. You're welcome. Anything?
One question that I do have, I might have missed it, but on the last exam at the end of it, we had kind of a where we kind of had to fill in the blank with, we had to crunch out some numbers. Are we gonna have that on this, or is it gonna be all multiple choice?
I'm going to go with all multiple choice on this one. Well, I take that back. There will be the matching still, the terminology, but the rest of it will be multiple choice.
Okay, thank you.
Sure, you're welcome, Spencer.
And I don't think I have anything.
All right.
I always ask this. This is my notorious question, but like if things pop up further, like between now and the exam, will you be available? Like if I just reach out with a quick email?
Oh, sure, of course. Yep, absolutely.
Thank you
Please
very
do.
much. Have
Feel
a good
free.
rest of your weekend.
Thanks, you too, Brent. Sorry, not Brent.
No worries.
Catherine, anything else?
I don't think so. Could you just like real quick on like the formula sheet?
Oh, yeah.
I was trying to go through with like all the like put like call equations
Uh-huh.
and differentiating between, so it's like a put call parity,
Mm-hmm.
and they all were like something different. Like which one exactly would I use for like a put call parity and like?
Sure. Well, yeah, all of the now what I've done is I've simply pulled all of the numbered formulas out of the textbook. So they've numbered this formula. The first three that you see here, right? This S plus P minus C is equal to K over 1 plus the risk-free rate raised to the teeth power. That one is identical to the next two. So the second one, all we've done is we've shifted. So let's see. What they have done is they have left the S on the side that it is. They've subtracted K over 1 plus R raised to the T from both sides. So that's where they get this.
Okay.
And then they've moved the C and the P over to the other side. So that's where they get this part of it. So those two are identical. And then the one below it, they've simply moved the K back over to the left-hand side and just flipped things around. So that one's identical. The only difference here with this one is that they've included the dividend. So this is actually the Black-Scholes, this is put call parity on a dividend-paying stock. So these three, either of those three, you can use. And you could even change this one. This one is particularly convenient because let's see. Let me blow it up so you can see. For some, I can't mark on here with this, but this S equals. So what you could do is, if you wanted it to be C equals, you could just subtract C from both sides and subtract S from both sides, and you would move the C over to the left, and you'd move the S over to the right. Then you'd have to multiply both sides by -1 again to get a positive C. And that would give you the formula for finding out the price of the call. If you knew the price of the stock, the put, and the exercise price. Likewise, you could do the same thing with the put, and you could even do the same thing with the K, not that you would ever want to do that, though.
Yeah.
So that one is particularly helpful because you can just move one term over to the left, isolate it, and then the sum of the other three terms is the value of that fourth term.
Okay. So say like you were to solve for like the calls with the C,
Uh-huh.
you use like C minus P, and when you add like the P to the other side.
Yes. Uh-huh. Yep. So if you use this one right here at the top, that one right there, you could add P to both sides. So that's going to cancel the P on the left-hand side.
Yeah.
And you'll have over here to the right, I can't write on this, but to the right of that capital T, you'd have plus P. Uh-huh.
Okay.
Yep.
It would be added like to the end.
Yeah. Yeah. That's the beauty of this formula, is that if you know any of the three, you can get the price of the fourth, which is kind of cool.
That's what I figured, because I was like trying to
do it with the practice problems we posted on Canvas,
Right.
I started getting confused, and then I was like, I looked up everything in the book.
Mhm.
I just wanted to make sure I had it like
Sure.
kind of correct. Okay.
Yeah. Yeah. No problem at all. Yeah. And yeah, so that's pretty. You know, if you wanted this one at the very top here might be the easiest one if you just wanted P over on the left-hand side. So what you would do, you would subtract S from both sides. That would move the S over to this side, and it would be a negative S. And you would add C to both sides, which would cancel the one over there, and you would have a plus C on this side.
Okay.
Yep.
I think that makes more sense now.
Okay.
Just knowing when I look.
Sure.
The other, like in the textbook, it's a little confusing, but that makes more sense then.
Okay.